Let us solve this first problem. So which is if f of 1 is 1 and f dash of 1 is equal to 3, then the derivative of this, okay, you got to find the derivative of this at x is equal to 1. Okay, so let us solve this problem. So let us solve this problem. What we have is there is a y is equal to uh, f of okay. So let us this is the function, right? So let us solve this problem. Okay. Now first is differentiating this, and then again this, and then this. Okay. So dy by dx is equal to uh, f dash of f of f of x. Okay. So close the brackets, and now let us differentiate this. So this is 1, 2, and 3. Let us differentiate this. So that will be f dash of f of x, right? Again, this function, okay? So which is f dash of x, right? And then this term, that is 2 into f of x, okay? Function of this, and f dash of this, right? So this is the first thing we are supposed to do. Now we have been given in the question itself when x is equal to 1. So let us substitute it. So f dash of f of 1, okay? So into f dash of f of 1, okay? Dash of 1 plus 2 into f of 1 into f dash of 1, okay? So that is equal to, so this is now f of 1 and f dash of 1 is given, which is 1, and then this is 3. So let us substitute it. So that is, so this is f of 1 again, this being 1, okay? So this is 1 again. So this is f dash of 1. So this is f dash of 1, right? Plus 2 f of 1 and f dash of 1. Okay, now let us substitute everything which we have. So this is f dash of f of 1 is 1, okay? F dash of 1, and this is f dash of 1 and 2 into f of 1 and f dash of 1. Now let us substitute all these, okay? So that is, let us substitute it. So let us substitute all the values which you have. That is um, this f dash of 1, which is 3, and this is 3 again, and 3 plus 2 into 1 into 3, right? So this is 3 cube, which is 27, and this is 6. So which results 33. So this is the required result. Now let us look at the second problem, which is y is equal to y of x being the solution of the curve, that is of the differential equation, right? And satisfies y of 0 as 1. So, and also we got to solve that this curve intersects the x-axis at a point whose abscissa is, right? So we have the choices. Let us see what is the best choice here. Now, this was our problem, and which will be satisfying y of 0 is equal to 1. Okay, so this is not of the proper form, which is supposed to be dx by dy plus p of y into x is equal to q of y. Okay, so which is a linear differential equation. Okay, so let us first find try to write in this form. So taking dy by dx on the right hand side, so you get y square minus x um, is equal to dy by dx. Okay, and let us rearrange this in this form. Okay, so dx by dy. Okay, so dx by dy plus x is equal to y square, right? Now, now we got in this form p of y is equal to 1 and q of y is equal to y square. So first thing is you got to find what is the integrating factor over here. Okay, so which is e to the power of p of y into dy, which is dy alone, which is e to the power of y. Now let us substitute it. Any doubts? Please ask. So, so we got integrating factor, which is e to the power of y. So our solution will be x into the integrating factor, which is e to the power of y, which is equal to integral y square into e to the power of y into dy. Now, further, let us uh, find this, right? So y square, so integrating this, so which is y square minus uh, 2y, and this is plus 2 into e to the power of y plus c. Okay, this is x into e to the power of y. Now, taking e to the power of y on the right hand side, so this cancels out. So you get x is equal to y square minus 2y plus 2 plus c into e to the power of minus y. Now for x is equal to 0 and y is equal to 1, we have been given y of 0, which is equal to 1, right? So let us substitute it. So 0, this is 1, and this is minus 2, and this is plus 2, and this is c into e to the power of minus 1. Okay, so these gets cancelled, and then this implies c is equal to minus e. Okay, we got c. Now, in the question, it was asked since the curve intersects at x-axis. So when you say that on the x-axis, so y will be 0 in the curve which is intersecting at x-axis. So if I draw a real line, so here x and y coordinates, okay, so intersects somewhere here. So on the x-axis, so you got to find what is x by substituting y as 0. So when you substitute y as 0 in this, so you get x is equal to, this is 0 plus 2, and this is c, which is minus e, and this will be e to the power of 0, which is 1. Okay, so x will be 2 minus e. So this is the required solution. Now let us look at another problem, that is y is equal to y of x be the solution of this. Okay, which is satisfying y of 0 is equal to 0, then y of 1 is equal to, right? So let us solve this. So let us solve this given differential equation which is given. Now we have to form this again in the form of dy by dx, right? Uh, plus, now this will be p of x into y is equal to q of x. So this we got to do this. Okay. So now if you look at multiply this whole thing, so this is e to the power of y and e to the power of x. Now, still I got here dy by dx has coefficient as e to the power of y. So I have to write in this form, right? So let us substitute e to the power of y as e to the power of t. Okay, sorry, as t. Okay, so that becomes easier. So when you differentiate this with respect to uh, x, so this becomes e to the power of y into dy by dx is equal to dt by dx. So your equation becomes, now if you look at this, so this is dt by dx, right, minus t is equal to e to the power of x. So this is the required uh, differential equation, okay, of the form. So p of x will be 1 when you compare to this, and q of x will be e to the power of x. Now let us solve this. Find the integrating factor. So let us move further solving this. So we found that p will be -1 and q is e to the power of x. So integrating factor will be e to the power of this is integral dx, and this is minus. So this is e to the power of minus x. So so t into e to the power of minus x, that is the integrating factor, is equal to integral e to the power of x into e to the power of minus x dx plus c. So this is dx, right? So integration of dx will be x, and this is c. And now this will be t. I'll get back the same function, which is t, which is e to the power of t, which we have taken as e to the power of y. Let us substitute this. So e to the power of y, and this is e to the power of minus x. So y minus x is equal to x plus c. Okay. So now to get the value of c, let us substitute. We have given a y of 0 is equal to 0. So x will be 0 and y will be 0. So this will be 0, e to the power of 0, and this is 0 plus c, or c is equal to 1. So this whole thing becomes e to the power of y minus x is equal to x plus 1, right? So further, let us solve. Any doubts? Please ask. So now we got e to the power of minus e to the power of y minus x is equal to x plus 1. Now taking logarithms on both sides, so you get y minus x is equal to log of x plus 1, right? Now at x is equal to 1, now we got to find when x is equal to 1. So y of 1, since it is a function of x, so y is a function of x, So y of 1 is 1. Uh, this is 1, okay, plus log 2 to the base e. So this is the required result. Please ask if you have any doubts. Please see the working. This. Now let us look at another problem. Considering two set, you have A and B. So which of the following is not true? Let us see this. Okay. So I've been given this set which is A, right? Now this set A, and we have given as M belongs to R, which is real numbers, and you have this quadratic equation, right? So these roots are also real. Okay, so we got this. So now this is in the form of which is f of x is equal to ax square plus bx plus c, right? So which is equal to 0, right? So since we have this real roots, then let us consider b square minus 4ac, which is greater than 0, right? So now you have the coefficient here. A is 1 and B is minus of m plus 1 and C is m plus 4. So let us substitute this. So this will be m plus 1 whole square minus 4 into A, which is 1, and C, which is m plus 4, right? So greater than 0, right? So if you look at this, okay, so this will be when solving this, you get m minus 5 and m plus 3, uh, which is less than 0. So further, so while looking into this, so m minus 5, which is greater than 0, and m plus 3, which is greater than 0, or m is greater than 5 and m is greater than minus 3. So um, we got this here, and also b, which is minus 3 comma 5, right? So now in the option which is A union B, so this belongs to the, which is not true. Okay. Now let us look at the fifth problem, that is set A has m elements and set B has n elements. So you go to, if the total number of subsets of A is 112 more than total number of subsets of B, then you got to find what is m into n. Okay, so these are the choices, and we'll see the best choice which we have. Okay, which we get. Okay, let us see that. So we have been given that a subset, the total number of subsets of A is 112 more than that of total number of subsets of B. So suppose if I consider number of elements of a set here as m elements, then number of elements in that will be n of A, which is m, and a set B, which has n elements, so which will be n of B, which is n. So now if you look at a subset of a set A will be 2 to the power of n, These are the subsets, and for this is 2 to the power of n. Now, now, how would we relate with that? Okay, so subset of A, that is 2 to the power of m, is equal to 112 more than subset of B. So 2 to the power of n plus 112. So when you get this equation. Now let us put all uh, this term on the left hand side, 2 to the power of m minus 2 to the power of n. So 112, uh, uh, when you try to simplify it, so you get 16 into 7. 16 multiplies 7 is 112. So 16 can be written as 2 to the power of 4. Okay, 7 can be written as 2 to the power of 8 minus 1. Okay, so this is 16 into 7. Okay, so this I can take 2 to the power of n, right? 2 to the power of m minus n minus 1. So this is, as you can see here, so 2 to the power of 4 into 2 to the power of 8 minus 1. Now compare this here. So you get n as 4 when you compare with this with this. So n as 4. M minus n, okay, m minus n is 2 to the power of 3, right? 3, sorry, 2 to the power of 3 is 8. So 7, which is 2 cube minus 1, which is 7, right? So this is 3, right? So m minus n, so this will result to m as 7. So in the question it was asked, what is m multiplied n? So that is 7 multiplied 4, which is equal to 28, is the best answer. Now let us look at the sixth question here. So if you see this here, a set A is this and set B is this. Okay. So what is the number of subsets of the set? Okay. A multiplied B. So let us see that. Okay. Now, if you look at the set A, right? So A, which is 2 to the power of x plus 2, right? Multiplied x square minus 5x plus 6 is equal to 1. Okay. Now, if you look at this, so I can write 1 as 2 to the power of 0. So I can compare this with respect to this, right? So that is 2 to the power of x plus 2, which is 2 to the power of 0. And this x square minus 5x plus 6, this is a quadratic equation which is equated to 0. So here, if I look at this, right? So x plus 2 will be 0 or x is minus 2. And for this, you get the factors as x minus 2 and x minus 3, which is equal to 0, or x as 2 comma 3. Now, if you combine these two, right? So, so you get the set A, which has got the elements minus 2, 2, and 3. So number of elements of a set A is 3. Okay. Now let us look at set B, which is defined as like this. That is under minus 3 less than 2x minus 1 less than 9. So, so this will be 1 minus 3 less than 2x less than 9 plus 1 when you add. So this becomes minus 2 less than 2x less than 10 when you divide it. by 5. So this is 1 less than x less than 5. So here uh, the elements, so that is minus 1, 0, 1, 2, 3, 4, 5. So this x belongs to that open interval which is minus 1 and 5. So minus 1 and 5. So you have the elements inside this is 0, 1, 2, 3, and 4. So we got 5 elements in this. So what we require is a multiplied b, which is subsets. So 2 to the power of m into n, which is 2 to the power of 15. Now let us look at seventh problem. So here, which is z, which is a complex number. So we have to compute this, and this is an inequality, right? Also given as inequality. Let us check this. So, so let us solve this problem. So we know z is x plus iy, which is a complex number. So mod z will be a square root of x square plus y square, right? And we know the real part of z will be x. This is a real part of z. Okay. So given that that is mod of z minus real part of z um, is less than or equal to 1, which is given. Okay. So let us write down. So square root of x square plus y square minus x less than or equal to 1. Okay, so bring on to the right hand side. So this will be x square plus y square less than or equal to 1 plus x. Now squaring this on both sides. So uh, what we get is x square plus y square is less than or equal to 1 plus x whole square. So now this is x square plus y square less than or equal to x square plus 1 plus 2x. So you can cancel these terms, right? So y square is less than or equal to 1 plus 2x, or further you can write as y square is less than or equal to 2 times x plus 1 by 2. So this is the best possible answer. So now let us look at the next problem when we have mod of z plus z is equal to x plus 1, right? So let us find the solution for this. So now that is, so from the previous question, we've already seen that z is x plus iy and mod z is square root of x square plus y square. Okay, so using those, right? So given that mod of z plus z is equal to 3 plus I, mod of z, which is a square root of x square plus y square, write this down, and z, which is x plus iy, which is equal to 3 plus I. What you can notice comparing this in real with and imaginary. So you can find that y is equal to 1 when comparing this. So y will be 1. So and this is x square plus y square plus x is equal to 3, right? So take this. So this will be x square plus y square is equal to 3 minus x, and squaring this on both sides, what you get is x square plus y square 3 minus x whole square, right? And when you simplify this, you get minus uh, and substituting x is equal to 1. Okay, we'll substitute that also. So x square plus 1 is equal to x square plus 9 minus 6x. So these terms gets cancelled. So you get minus 8 is equal to minus 6x, uh, which x is 4 by 3. So now we got what is x and what is y. So we need what is mod of z. So z, which is 4 by 3 plus I, right? So mod z will be square root of this is 4 square, which is 16, and 3 square, which is 9. This is 1. So this is root 25 by 9, right? So which is 5 by 3 is the possible, best possible answer. Now let us look at next problem. Uh, we have given a lambda, which is the ratio of the roots of the quadratic equation, which is given for this. So what will be the least value? Okay, let us find the solution for this. Okay, so let us see that. Okay, so uh, as we have seen that lambda is equal to the ratio of the roots. Let alpha and beta be the roots. So alpha by beta. So this is the ratio here. Okay. Now as we know that sum of the roots is alpha plus beta, which is equal to minus b by a, which is the formula, and uh, and the product, which is alpha into beta, is c by a. Okay, please remember this. Okay, for the general equation ax square plus bx plus c is equal to 0, right? Now we are being given that 3m square x square plus m into uh, m minus 4 into x plus 2 is equal to 0. So you can find here this as a and this as b and this as the constant c. So let us put down. So alpha plus beta is equal to minus of um, m into m minus 4 divided by uh, 3m square, and alpha into beta, that is a product, which is 2 by 3m square, right? So um, we are being given that lambda plus 1 by lambda is equal to 1. So we already know what is lambda, which is the ratio of the roots of the quadratic equation, which is alpha by beta. Let us write down alpha by beta, and the reciprocal of lambda is 1 by lambda, which is beta by alpha, which is equal to this, is equal to 1. So this is alpha square plus beta square is equal to alpha beta. Now we have been given the alpha plus beta as this and alpha beta. So what we need to write is alpha beta whole square. Okay, so I have subtracted it. So with minus 2 alpha. So when you get on the right hand side, it is 3 alpha beta. Okay, so let us substitute alpha plus beta and alpha multiplied beta. So let us see that. So alpha plus beta whole square will be minus m into minus m minus 4 by 3m square whole square is equal to 3 times alpha beta, which is 2 by 3 m square. Okay, So this is m square into m minus 4 whole square divided by this is 3m square multiplied 3n square. So I can simplify uh, the terms, right? So this is 6 divided by 3m square. So you can cancel this out, right? And this term and these terms you can multiply if it goes to the other side. So you get m minus 4 whole square, which is equal to 18. Okay, further simplifying, you get m square minus 8m uh, minus 2 is equal to 0. So when you find the roots of this equation, m is 4 plus or minus 3 root 2. And in the question, it was asked what is the least value of m, right? So the least value of m will be 4 minus 3 root 2. So this is your answer. So let us look at another problem. The root of this equation is given like this, which lies on the curve, right? So z is a complex number, right? So let us see the best possible answer for this. Okay, so let us see that. Okay, so what we have here, uh, as we know that z, which is x plus iy. Now the roots of this has been given, so I'll write in the terms of alpha and beta. So z is alpha plus I beta. Okay, so given that x square plus bx plus 45 is equal to 0. So now if you have alpha plus I beta as one root, the conjugate will be alpha minus I beta. Now the sum, okay, sum is alpha plus beta. So this you consider as one root and this as another root. So uh, as we have seen in the previous problem, alpha plus beta, it is alpha plus I beta. This is a complex number and plus alpha minus I beta. So this is minus b by a. So as you can see here, a in this, a is 1, b uh, is b, right? And c is 45. So minus b by a is minus b by a, which is 1. Okay. So sum you get as 2 alpha, 2 alpha is equal to minus b, okay, or alpha is equal to minus b by 2. You got this result. Keep this result. And now the product. Product is these two roots you multiply, that is alpha and beta. Okay. So this will be alpha plus I beta multiplied alpha minus I beta, which is equal to c by a, which is 45. So this is alpha square, I square. We know that I square is minus 1. Okay. So alpha square plus beta square is equal to 40. Okay. Keep this equation 2. Now, in the given problem, mod of z plus 1 is equal to 2 root 10. Okay. So z is alpha plus I beta plus 1 is equal to 2 root 10. So bring on the real terms, alpha plus 1 I beta is equal to 2 root 10. Now mod of z is square root of x square plus y square. So here this implies square root of alpha plus 1 whole square plus beta square is equal to 2 root. Okay. Further, let us simplify. So, as you notice that we had square root of alpha plus 1 whole square plus beta square, which is equal to 2 root 10. Right? Squaring on both the sides of the equation. So you get alpha plus 1 whole square plus beta square, which is equal to, this is whole square, so this will be 40. Okay. So let us substitute what is alpha minus b by 2 and alpha square plus beta square as 45. So this is alpha square plus beta square plus 2 alpha plus 1 is equal to 50, or this is 45 plus 2 into minus b by 2 plus 1 is equal to 40, or we simplify this, minus b is equal to minus 6, or b is equal to 6. So let us check each and every result when you find all these results. So b square plus b is equal to 12. No, it is not working out. So let us see the next one. B square minus b, is it 30? So yeah, it is 30. So this is the best possible answer. Now let us look at another problem wherein P and Q belongs to R. If one root is there, that is 2 minus root 3. Minus root 3 is the root, okay, of the some quadratic equation. Then what would be the best choice on this, right? So let us see how do we solve this. So the given equation, which is x square plus px plus q is equal to 0. Okay, this is given, and one root is given, that is 2 minus root 3. The other root will be the conjugate of this, that is 2 plus root 3. So we know that sum is equal to alpha plus beta, right? So which is equal to minus b by a, right? So if you consider this as one root and this is another root, alpha and beta, so 2 minus root 3 plus 2 plus root 3, which is minus b by a. Here, if you look at this, here a is 1, b is p, and c is q. Let's put that minus b by a, which is minus p. So we got p as minus 4, okay, when we sum the two roots, okay. So the product will be alpha into beta, which is c by a, okay. So the first root is 2 minus root 3, and the second root is 2 plus root 3. So which is q by a, that is, which is q. So this is 4 minus 3, which is equal to q, or q is equal to 1. So we got p and q. So uh, here, as a, let us substitute p and the q values for the given first choice, which is q square plus p square plus 14. Okay, let us see. Q is 1, right? Q square, 1 square, and 4 into minus 4 plus 14. So, which is not equal to 0. so which does not satisfy the equation. Let us have a look at that is p square minus 4q minus 12, right? So p square, which is 16, right? And minus 4, right, into 1, right, which is again minus 4 only. So minus 12. So which is results to 0. So the required result is p square minus 4q minus 12 is equal to 0. So this is uh, the answer. Let us look at another problem. You got the area of the region which is enclosed by the circle, which is x square plus y square is equal to 0 and is not common, okay, to the region which is bounded by the parabola, which is y square is equal to x, and the straight line which is y is equal to x. So let us see the possible answers. Okay, so well, well, the equation of the circle, which is x square plus y square is equal to 2. So the general form of this will be x square plus y square is equal to r square. So so here the area, which is equal to 2 pi r square, or area is equal to sorry, area is pi r square, uh, which is 2 pi. Okay, and also we have been given the curve, that is y is equal to x, and y square is equal to x. Okay, so x will be ranging from 0 to 1 here, and here x also will be ranging from 0 to 1. So let us look at the required area. So the required area is area will be 2 pi minus um, that is area which is enclosed by y square is equal to x, and y is equal to x. So this which is you need to find. Okay, so let us move further. And so this is the figure. This is the circle, which is x square plus y square is equal to 2. And you have the straight line y is equal to x, and the curve, the parabola, which is y square is equal to x. Okay, and this is the region which we are going to find, r. Okay, so required area. So that is 2 pi. Now this will be minus integral. As I said, x ranges from 0 to 1, right? And y square is x, or root x minus x, right, into dx. Okay. So when we try to simplify, 2 pi minus, this will be 2x e by 2 by 3 minus x square by 2. Okay, 0 to 1. Fine. So this is 2 pi minus 2 by 3 minus 1 by 2, which is equal to, after simplifying, this will be 12 pi minus 1 by 6. So this is the required. So now let us look at another problem wherein the region is this, right? So uh, that is, you got to find the area, that region. Okay. So let us find the solution for this, right? So let us see that how do we solve it. Okay, so here we have x comma y, which belongs to R2, which is two-dimensional x and y plane. So uh, the given is 4x square, is less than equal to y, okay, is less than equal to 8x plus 12. So this means that y is equal to 4x square and y is equal to 8x plus 12. So these we get from this inequality. So if you look at this, y is common for both. So this will be 4x squared, which is equal to 8x plus 12, or this is your f of x. Okay. So minus and minus is equal to 0. This is your f of x. Okay. And when we rewrite this, so this is x squared minus 2x minus 3 is equal to 0. To get the roots, which is x belongs to minus 1 and 3. So we got x values. Okay. So let us have a look at the figure. So we got this. This is the curve, okay, which is y is equal to 8x plus 12, and this is, I mean, I guess this is y is equal to 4x square, right? So this is the equation of the straight line. Y is equal to 8x plus 12, and these are the limits, and this is the required region. Okay, this is the required region. Okay, so yeah, so we got the uh, limits, which is required area, which is equal to minus 1 to 3. Uh, this is your equation, which is this 8x plus 12 minus 4x square, okay, which is dx. So which will be 8 by 2x square under the limit minus 1 to 3, and plus 12x minus 1 to 3, and this is minus 4x cubed by 3 minus 1 to 3. So which will lead to 128 by 3. So this is the required solution, or the area region. So here you can see the region. Okay, so this is the region which we get. Okay, let us look at next problem. That is the image. The image of the interval is minus 1 and 3. Okay, and under the mapping R to R, function R to R, your function is given. So let us look at this. Okay, fine. So let us solve that. So let us consider the interval 1 minus 1 comma 3, which is which can be written as minus 1 comma 1 union 1 and 3. Okay, so the function f of x is 4x cube minus 12x. Okay, so when you put my x as minus 1, you get this as 8, and if you put f of that is 0, which is 0, and 1. If I put, you get -8. Okay, and let us put f of 3 here. So if I put uh, the value of 3, so we get 72. So can see here, so -1 and 3 are the endpoints. So here the best choice for the mapping R to R, the function R to R, which is -8 comma 72. Now let us look at another problem. If A is 1 comma 2 and B is 3 comma 4, so number of relations, so R, okay, so from A to B, what will be? And also I'll be solving this also, 16th one, the number of relations of set A of n elements, 2 to the power of 16. So both this. Okay, let us have a look at this. How do we solve it? Okay. So we know that the relation, we know that the total number of relation, okay, total number of relation uh, on A of the set A uh, from A to B, right? A to B is A has got um, has two elements, 1 and 2. Okay, B has got 3 and 4. So here you can see two elements. So the number of relations from A to B will be 2 to the power of m into n, which is 2 into 2, which is 2 to the power of 4. Okay, and uh, and we'll have a look at the second one. Okay, so here if the number of relations on a finite set A n elements, so which is 2 to the power of 6, then what will be the value of n? So let us see that. Okay, so here we know that the total number of relations in a finite set having n elements will be 2, which is n into n. So A to A, right? A has got n elements. Again, B, which is represent as A, which has got n elements. So which is 2 to the power of n into n, or can be written as 2 to the power of n square, which is equal to 2 to the power of 16. So n square will be 16, or n is 4. So this is the answer. Okay.